play the math match multiplication easy game. And to run this program, we are going to start off in the gamelogic.asm file. So this one serves as our main file, basically. So the first thing you'll notice is right down here, we go ahead and we initially go to main card logic. And so main card logic is a global symbol, which is a function in card logic here. And so what main card logic does, what main card logic does is it goes ahead and it loops adding it runs this populate arrays function. And the importance of this populate arrays function is it takes two random values from 2 to 5. It goes ahead and calculates the result, and it passes the two x and y values into the problem values array, and then it puts the result into result values. And so I'll explain the importance of that in one moment. But after we do that, we go ahead and increment the counters, which are instrumental to figuring out the offset for these arrays. So we do that, and we jump back up, and it does this 8 times. And so after it does this 8 times, it'll go down to cards done here, which will jump right back up here, which will jump back into game logic. And so this is all part of the setup. And so right after that, it'll jump to this function right here, randomize arrays, which is also in card logic. And so what randomize arrays does is it takes those two arrays from earlier, the problem values and result values arrays, and it will randomly input them into the display order array. And so this is how we make the game interesting, by not leaving the values right next to each other, the matches right next to each other. So randomize arrays, what it will do is it will randomly take an integer from 0 to 15, right? So it'll be an index in the display order array, and it will calculate offset, figure out if there is a value already in that index, which in that case, it will loop back up and randomly select another integer. Or if there's nothing in that array index, right, what it will do is it will stick it in right here. It will store the word into display order and branch right back, or loop right back up to the top of the loop. And it will run that for every single one of the problems, expressions, right? And once that's done, it will go down here to result randomize, which will loop this. It will do the exact same thing just for the result array. And so by the end of it, it should have set up an array perfectly randomized with expressions and values. So once that is done, we will go ahead and start the game. So now all the setup's done. So what happens is we jump to this function, initialize timer. What initialize timer does is it goes ahead and it grabs the syscall. It does syscall 30. It gets the current time, and that will be our start time. It will go ahead and store that time, which will be stored throughout the program. And any time that we need to check the time, right, we will call this function check timer, which will calculate the difference between the initial timer and the current time, and it will print out the current time. So once the timer is initialized, we will go to display board. Display board does exactly what it sounds like. It will display the board, which is a bunch of ASCII characters. And so display board, what it first does is use incrementers, right, to figure out column and row, and then it will use this array right here, the bool array, to determine if a card has been flipped or not. So if a card hasn't been flipped, right here, card unknown, it will just print a question mark, which is perfect. But if it has been flipped, it will go down here. It will go ahead, read the card at the display, in the display order array, and it will go ahead and print that out. So it's pretty simple. It will loop through all of that, and then once it's done, we come back into game logic, and here is where the fun begins. So we jump into the game loop. And so what the game loop does is it will take input from the user right here. It will get row and column, and then from there, it will calculate the index given those two inputs, find that offset, and determine if that index is valid, right? So if there's any input that's just not like valid, right? If it's not between 1 and 4, or if the index is, well, calculated improperly, just whatever goes wrong, it will go ahead and give an error and jump back up to the input statements. That way they can re-input their choices. After it's validated the input, it will go ahead, use that Boolean array to flip the card, right? It hasn't been flipped yet, but when the display function is run, the card's value will be printed. And then it will also store the result of the card. So here's what I'm talking about. It will flip the card here with set bool array, and then it will get the card and store that card's result into S2 here. And that's important for determining if there is a match later on. So then it will go ahead, display the board again, implement some sound. So every time the card's flipped, we will play this lovely sound that you will get to hear when we play it in a moment. And then it simply does the exact same thing again for a second input. So you see the input statements, the calculating offset, the validation. Come down here, you get the flip, the display, and ultimately determining the value of the card. So right here is where we figure out if there is a match. So this branch right here will determine if the two cards that they have flipped, if their results are matching. If so, then all we do is we go ahead and implement this sound right here, which will be a nice lovely sound to let you know that you have indeed gotten a match. It will decrement the cards, which is important because what it does is, so every time you enter your second input, it will display how many cards you have remaining to flip. And so if you get it correct, we want to go into here, so decrement cards. What it does is it simply just subtracts 2 from the cards remaining. And then later you'll see we'll call the display cards, which will just print the remaining cards. All right, and then once that's done, we will display just a string letting them know that they got it correct, display the cards, check timer, which will print out the time, the current time taken. And then right here, it will check if all of the cards have been flipped. And so if all of the cards have been flipped, we would go into the game over function, which simply lets you know that you won and ends the program. If not, it will go back up to game loop at the top, and it will rerun all the input. Now, if you get it wrong, there's a little bit extra. So first we need to set the bool array. So we need to unflip the cards, and then the rest is pretty similar. We just let them know they got it wrong. Go ahead and display how many cards are remaining. Go ahead, give a little sound, and then print out the time taken. And so we're going to go ahead and run this program and see what it looks like. So we'll go ahead and start it up here. So already we see that the display is printed, none of the cards have been flipped, and it's prompting for input. And so already here in the data, where is it? It's somewhere in there. The arrays are there, which hold all the info on the cards and the display order. So you'll see here, so just to show the input validation, so if I enter 5 for a row and then say 1 for the column, it will go ahead and let us know that the input given is invalid or we've already flipped the card. So let's go ahead and flip the first card. And so see, it prints the display again and it shows us the expression that's held there, right? So 2 times 4. So now obviously we want to match that up. And so let's say we say, oh, 2 times 4. Well, I know where 2 times 4 is. It's in the first card, right? Oh, well, it doesn't let us do that. It's already been flipped. So it asks for a different input. So let's go ahead and put in the first card in the second row. Oh, look at that. We got a match already. So notice here, it shows that there are only 14 cards left, right? So, because we've flipped over 2 and it's correct. And then it's also telling us that we took 1 minute and 16 seconds to get there. So let's go ahead and get one wrong. So unless I'm too good at the game, let's see, 3 times 5, and then what if we flip that one? 4 times 5, right? That's not good. So it tells us that we did not get a match. There are still 14 cards left, and the total time taken is 1 minute and 43 seconds. And you can hear the sound, hopefully, coming through the video for all for the correct and wrong matches. And so if we keep going, should I go all the way? So let's keep going and show the ending. Oh, and so if I can find the data, I'd love to show, here it is. Here's the data, I found it. So right here, we notice the F, the 8, right, 2, 0, the 2 and the 3, the 5 and the 5. So these are the, that's the card order, right? So it's completely randomized. So F is a result, 8 is a result. See 2 expressions here, right? So this is the, that's where the display order is held. And then if it shows it down here, here, okay, so notice how we've flipped over one, like the first card and the 5th card, so the 2 times 4 and the 8 are both correct. So if we check the Boolean array here, we can see, so this one right here, this is the first card. Notice we flipped the second one, but it wasn't a match, and so the Boolean array is switched back to 0 because it doesn't want it to be flipped. And then you go 3rd, 4th, 5th card, it also shows a 1 because that one is flipped. And I can show you here really quickly, if we flip over the second card again, the Boolean array, here, I guess I have to do that to update it. Here, the Boolean array has been updated to show the 1 there. So let's keep playing. Let's see. 2, and then 4, 4, 3, 1. Okay, so notice here we're almost at the very end. We only have 2 cards left. We've taken 5 minutes 42 seconds. Not my fastest, not my best attempt here, but you'll see we flipped 1 card, right? So this 2 times 4, right? And then we have 1 card remaining. So when I go ahead and enter this value here, card 3, 1, what it should do is it should go ahead and end the game, right? So let's go ahead and let's check that out. There we go. And it played a nice little melody for us, courtesy of Deep. It shows us that we found the match, there's no cards remaining, and it tells us the time we took and that we won. And that is how the program works. So just a nice, simple, easy math game.